So chapter 6 is on thermochemistry, which has to do with energy changes that happen with chemical reactions. So again, we're going to split this chapter into 5 main skills. The first is just learning about some basics about what we call thermodynamics. It's the study of energy and sort of its transformations. Then we learn about one component of this energy, which is enthalpy. One of the things to remember that's important about sort of the energy changes that happen is the first law of thermodynamics, which states that we cannot create or destroy energy. We just change it into different forms. And that philosophy is going to be really important as we use some of the equations that are important to this chapter. So again, we think about thermodynamics and energy changes with regards to enthalpy in this chapter. And when we think about enthalpy, you want to think about heat. So we're going to talk about exothermic or endothermic reactions. So endothermic reactions being ones that take in energy as heat, and then exothermic reactions are ones that give off energy. Thinking about enthalpy, enthalpy is, again, a value of heat energy that's applied to a specific equation, so we can create a unit conversion that allows us to walk another way to moles. So now we can relate the moles that we have in a balanced chemical equation to the amount of heat that's generated. So again, another way to expand our mole game and make it even more robust. So one of the main sort of kinds of calculations that we did in this chapter was on something called heat capacity. So heat capacity is that Q being heat, equals C, which is the specific heat capacity, times M, which is mass, times the change in temperature. So just like we saw with gas laws, we can have 2 flavors of this equation, or these calculations. We can have sort of an unknown, where we're going to be solving for either Q, which is heat, specific heat capacity, mass, or temperature change. Or we can say, via the first law of thermodynamics, that energy is just transferred between 2 systems, and we can set that M, C, and delta T equal to each other for 2 different systems and talk about the heat transfer that happens between systems. And again, always solving for one variable. A lot of you have commented on the fact that you get to these problems and maybe you understand the chemistry, but then getting through the algebra at the end has been a little bit of a challenge. So keep that in mind, that working on solving equations for single variables is going to be a really important skill for this chapter. So the last thing that we sort of dealt with in this chapter was something called Hess's law. So Hess's law has us think about calculating delta H by manipulating equations that have given delta H's. So we learned about how to manipulate equations and how that changed delta H, but now we know we can have multiple equations that we utilize and sum up to give a new overall equation that maybe we can't perform that chemistry in the lab. And the last thing related to this is enthalpy using Appendix B, which is the enthalpies of formation. And remember, what we kind of imagine is taking our reactants and using energy to completely break them apart to their component elements. And then we recombine those elements to make our products. And summing up that information, and again using all of that data from Appendix D or B, is going to allow us to determine the enthalpy again for an unknown reaction. So lots of kind of more physics sort of based chemistry that we see in this chapter, but again we see sprinkled in aspects of chemistry like stoichiometry, we see moles and things like that, which will allow us to tie together previous concepts.